Hey guys, I hope you're staying safe in this hard time. Do some stretching and buckle up. We have a long video today. We're talking about radical expressions. Hey guys, this is Franck. Welcome back. Today we're going to cover radical expression. Last time we were here, we covered exponential expressions, and you can think of radical expression as an extension of that, because this time it's about fractional exponent. Alright, let's just jump into it. What does it mean to find the root of a number, to find the square root of a number, or the cube root, or even the nth root? Right? So if I ask you to find the nth root of a number, what I'm asking you to do is find a number b such that b to the power of n equals a. So that means for you to find b so that when you multiply b by itself n time, you get a. In the notation nth root of a here, the n represents the root number, the root expression here is the radical, and then a is the number you're finding the root for. Another way to rewrite this expression would be a to the power of 1 over n. In a more general way, you could write a to the power of m divided by n. And so when you see something like this, and a number raised to a power that's written as a fraction, you should know that the bottom part of the fraction represents the root, and the top part represents the power. So this is the same thing as writing the nth root of a raised to the power of m. Now here are some quick examples. So if I say the square root of 4, the square root of 4 here is going to be 2 because 2 times 2, twice, 2 times, gives you 4. If I ask you for the cube root of 8, that's going to be 2 because 2 times 2 times 2 is going to be 8. And also notice that if I don't put anything behind the radical here, it's assumed in general that the number that is 2. If I ask you for the cube root of 27, you're going to get 3 for the same reason as before. Now, if I ask you for the square root of negative 4, now this doesn't exist. And the reason why is because if you try 2, 2 times 2 is 4, but if you try negative 2 times negative 2 is still 4. So that doesn't work. And then if I ask you for the cube root of negative 8, then that's equal to negative 2. Because, of course, negative 2 times negative 2 times negative 2 should give you negative 8. Because there's 3 negative signs, and together they turn into a negative sign again. Same thing here. The fifth root of negative 1 is going to be negative 1. All right, so there's 2 things I want you to take away from this. The first thing is that A, the number you're trying to find a root for, and B, the actual root, have to have the same sign, as you can see in these examples. The second thing you want to take away from this is that even root of negative numbers do not exist because you can't multiply a negative number an even number of times and get another negative number. Right? So that doesn't exist. All right, let's move on. Here's another example. The fourth root of 81. Now, how do you tackle this one, right? Now, the numbers here are getting bigger, so we're getting more serious, right? And so usually when numbers are getting bigger like this, most of us are going to resort to guessing and figure out, oh, what number do I multiply by itself 4 times to give me 81? So if you started guessing, you would say, oh, is it 1? Well, if you get 1 times 1 times 1 times 1, that will give you 1. So this is not 81, so 1 doesn't work. And then you say, oh, so is it 2? And so 2 times 2 times 2 times 2, that's going to give you 4 times 4, that's 16, still shy of 81, so that's not the answer either. And then you go a little bit bigger because you want the answer to get a little bit bigger. And so 3, you get 3 times 3 times 3 times 3, that's 9 times 9, and that's 81. So you find them, right? Because you have 4 different 3's that multiply together to give you what you were looking for, 81. And so the fourth root of 81 here is going to be 3, and you're done, right? Now, this method can be time consuming if the number is too large or if the number is not a perfect root. And so let's look at a more systematic way to look for roots of numbers or root of expressions for that matter. So in this next example, I'm going to use the variable x in my root as well to make it a full algebraic expression. And the variable x is going to be a non-negative variable. So for the first example here, let's look at the square root of 45x squared. What I'm going to do here to figure out how to simplify this expression is to break the numbers in there. I'm going to break the factors under the radical 45, and x squared, I'm going to break them into their smallest factors. I'm going to find the factorial decomposition for those numbers. What I mean by that is, let's take 45 to the side here. I'm going to show you. So if you take 45 here, you got to ask yourself, what is the smallest whole number other than 1 that divides into 45 evenly? And so if you do 2 here, 2 doesn't work because 45 is odd. And so you try 3. 45 divided by 3 is going to give you 15, so that's perfect. So you put a 15 here, and then you just keep going. And so you try 3 again, and that gives you 5, and then 3 doesn't work anymore, and you try 5, 5 does work, and then you get to 1. When you get to 1 here, you can stop. So what this tells you is that 45 can be written as 3 times 3 times 5. And so if you go back to our root here, you can replace 45 here by 3 times 3 times 5, and replace the x squared here by x times x. So since you're looking for the square root, you want to have any group of 2 numbers here to get at the radical. So you got 3 and 3 here, that would get out of the radical to be 3 because you're looking for the square root. And you have x and x here, that gets out to be x. And then you have 5 here by itself that cannot get out because it doesn't have another 5 attached to him. And so you're going to have for your final answer 3x root 5. In our next example here, I'm going to have the square root of 10x multiplied by the square root of 8x. Now, because these are factors, meaning they are multiplying each other, I can actually push them all together under the same root. So I'm going to have the square root of 10x, 8x. And so I'm going to go ahead and break this 10 and this 8 onto their factorial decomposition. So I'm going to have 10 here. What number divides 10 perfectly? Start with the smallest one possible, except from 1. So 2 works, and then that gives you 5, and we know 5 is the one that divides 5, and that's done. And then 8, you try 2 works and gives you 4, and then 2 again, that works, and gives you 2 again, that works, and then 1, and then we are done. So we're going to rewrite our expression here as 2 times 5 times x times 2 times 2 times 2 times x. And so now we can take the square root very easily because we have to look at pairs of numbers here to be able to push them out. So we have 2 and 2 here, that gets out to be 2. 2 and 2 here gets out to be 2. X and x get out together, and then the 5 is stuck there. So you're going to have 2 times x root 5, which gives you 4x root 5, and then you're done with that one as well. Okay, let's look at another one to make this sink in. So you have here the cube root of 125. So let's break 125 into its factorial decomposition. Now, let's pause here for a moment. You don't have to do factorial decomposition all the time. I'm doing this because it's systematic and it will give me the right answer all the time. If you know what the answer is already, you can just write it out and then you should be good. But for those of us who have to think about it and don't want to guess, this is a good method to go for. All right, so you're going to have 125, and that's going to be 5, dividing 125 to be 25, and then 5 again, and then 5 again. So what this is telling you is that 125 can be written as 5 times 5 times 5. And so if you're looking for the cube root here, 3, cube root, you need to look for any groups of 3 numbers under the radical to be able to make them escape. So you're going to have 5, 5, 5 here, that's perfect. And so that gets out of the radical, and that gives you 5, and then you're done there. All right, let's look at the next one here. Next one, I'm going to throw a curveball here. Not really. I'm going to have a natural fractional exponent, not a simple one. So you're going to have 125 here to the power of 2/3, right? Every time you have a power that is a fractional power, note that the denominator of the fraction is going to be your root, and the numerator is going to be your power. So you can rewrite this expression here as the cube root of 125 all together raised to the power of 2. And so we already know that the cube root of 125 is 5, so you're going to have 5 squared. That gives you 25, and you're done. Next example, let's look at the cube root of x to the power of 4. So x to the power of 4 here can be written as x times x times x times x. And so you're looking for any groupings of 3 numbers to get out. So you're going to have x, x, x here. That gets out to be x. And then the x here is stuck because it doesn't have any more x to go with. So you're going to have x and then multiply by. the cube root of x. And then you're done with that one. Last example in this category, let's look at 25, x to the power of 4, y to the power of negative 6, altogether raised to the power of 1/2. Now remember, even if this is a fractional exponent, it's still an exponent. So remember the rule from the last lecture that we had. We can just go ahead and share this exponent to all the factors in the parentheses. And so you're going to have 25 raised to the power of 1/2, x raised to the power of 4 times 1/2, which is 4/2, and then y raised to the power of negative 6/2. And so that's going to give you 5 for the square root of 25, and then that's going to give you x squared, and then y to the power of negative 3. And if you remember from last lecture, I said that it was preferable not to have any negative exponent in your final answer. So you can turn this y to the power of negative 3 into a y to the power of 3 if you bring it to the denominator. So you're going to have for your final answer 5x to the power of 2 divided by y to the power of 3. All right, just like exponents, for radical as well, there is a preferable form in that you want to get your answer to. For this case here, for radical, you don't want to have any radical on a denominator. It's not preferable. So let me give you some example. So if I give you something to simplify that is a radical, and you don't simplifying it, but you find your final answer to have something in the denominator like 13 divided by 3 plus square root of 11. Now, if you have something like this, the teacher will usually ask you to rationalize your answer. What it means by that is to get rid of the radical under the denominator. To do that, all you have to do is multiply the fraction by the conjugate of the denominator, which means to switch the sign between the terms in there. So you're going to have 3 minus 11 divided by 3 minus 11, and then you have to multiply this through, and so you're going to get 39 minus 13 root 11. And then on the bottom, you're going to FOIL. So you're going to have 3 times 3, which is 9, 3 times negative 11, which is negative 3 root 11. And then root 11 times 3 is going to give you plus 3 root 11. And then root 11 times root 11 will give you root 11 times 11. Now, the reason why you do the conjugate is for this reason down here, because you're going to have the terms in the middle here cancel, and so that will get rid of the root. And so you're going to have for your final answer 39 minus 13 root 11 divided by negative 2. Next example here, let's look at 6 divided by root 5 minus root 3. We do the same thing here, multiply by the conjugate of the denominator. You're going to have root 5 plus root 3, root 5 plus root 3. Multiply it through, that's going to be 6 multiplied by root 5 plus root 3. And on the bottom, you're going to have 5, and then plus 15, and then minus 15, and then minus root 3 times root 3, which is 3. And then that's going to give you, if you do 5 minus 3, you get 2. And then the 6 divided by 2 will give you 3. So you're going to have 3 multiplied by root 5 plus root 3. And here you can stop, because there's no way for you to combine root 5 plus root 3 and give something else, because those are terms. Radical and terms do not mess with each other. So you cannot merge these two together and say, oh, this is root of 8, because that's a common mistake people do. Don't do that. You can only merge root together if you're talking about factors, right? So this is done. Let's look at our next example here. So you have 1 over the square root of 7. And so this is going to be multiply both numerator and denominator by root 7 and root 7, right? So here you don't need to do any conjugate because there's only one term in the denominator that has a square root. You have to just multiply by that same square root, and then you will get rid of the square root, right? If you do the conjugate here, let's say you multiply by negative 7 divided by negative 7, it's going to be the same thing because minus over minus is just plus, so it doesn't matter. So you're going to have square root of 7 on top, and on the bottom here, you're going to have square root of 7 times square root of 7. That will give you 7, right? And then the last one here I want to show you is, what if you have root 7 on top and then divided by root 3 on the bottom? Well, same story. You don't want a square root of 3 on the bottom, so you're going to have to multiply this expression by root 3 divided by root 3. And so on the top, you're going to have root 7 times root 3. Here you can actually merge them together and get root 21 because they are factors. They are multiplying each other. unlike the terms before that were not multiplying each other. So you're going to have root 21 here divided by root 3 times root 3, which gives you root 9, which gives you 3. Alright guys, that is it for now. The link for this note is always going to be in the description below. If you like this video, don't forget to share, like, and subscribe. Also, follow me on my other social platforms on Facebook, Instagram, Snapchat, and Twitter at Franck's Note, and I will see you in the next video.